Children, now we are discussing parallel combination of capacitors. Look here, these are the three capacitors of capacitance C1, capacitance C2 and capacitance C3. One end of each capacitor is connected to this point and another end of each capacitor is connected to this point. Okay, now look here, first we need to study what is the charge distribution on them and what is the potential difference across each capacitors. That is our interest here. Look here, potential will only drop when it gets some resistance or some work is done. Now look here, let me take this is the battery and this is the higher potential, this is the lower potential, this is positive terminal, this is negative terminal. Let me take this as some voltage, okay, this as the potential which is equal to 10 volt. For an example purpose I am taking this, I want you to understand this. So let me write that in a different color. Okay, potential of this terminal I will take plus 10 volt and this is minus 10 volt. Okay, positive terminal has 10 volt and negative has minus 10 volt. Look here, when I travel from this point to this point, this is the wire, this is the conductor, and conductor has negligible resistance. So here there is no resistance, no work done, no resistance, no work done. Here no work done. Up to here they will not have potential drop. Look here, from this terminal when I move to this point there is no potential drop. Here no potential drop. Here look here minus 10 volt is the potential, and if I move here no potential change, no potential change. Why? There is no resistance in this wire. So if I come here also potential is minus 10V, here this is plus 10V. What is the potential difference? Plus 10V minus of minus 10V, 20 volt. Illestitu illu kuda 20 volt, 10 volt minus of minus 10 volt estagutte ಈಗ, that is 20 volt. ಈ ಕೆಪಾಸಿಟರ್ಸ್ ಈ ಪಾಯಿಂಟ್ ಇವೆರಡು ಪಾಯಿಂಟ್ ಮಧ್ಯೆ ಎಷ್ಟಿದೆ? 20 ವೋಲ್ಟ್. ಯಾಕೆ? ಈ ಪಾಯಿಂಟ್ನಲ್ಲಿ 10 ವೋಲ್ಟ್ ಇದೆ, ಈ ಪಾಯಿಂಟಲ್ಲಿ minus 10 ವೋಲ್ಟ್ ಇದೆ. ಓಕೆ, ಲೆಟ್ ಅಸ್ ಚೆಕ್ ದಿಸ್ ಕೆಪಾಸಿಟರ್. ಓಕೆ, ಹಿಯರ್ 10 ವೋಲ್ಟ್ 10 ವೋಲ್ಟ್ 10 ವೋಲ್ಟ್. ಹಿಯರ್ ಐ ಕಮ್ ಹಿಯರ್ 10 ವೋಲ್ಟ್, ಹಿಯರ್ ಪ್ಲಸ್ 10 ವೋಲ್ಟ್, ನೋ ಪೊಟೆನ್ಷಿಯಲ್ ಡ್ರಾಪ್. ಹಿಯರ್ ಫ್ರಮ್ ದಿಸ್ ಟರ್ಮಿನಲ್ ಈ ಕಡೆಯಿಂದ ಇಲ್ಲಿಗೆ ಮೂವ್ ಆಗ್ತೀನಿ. ನಾನು ಇಲ್ಲಿ ಹೋಗ್ಬೇಕಾದ್ರೆ ಬರೀ ಕಂಡಕ್ಟರ್ ಸಿಗ್ತಾ ಇದೆ, ನನಗೆ ಬೇರೆ ಯಾವ ಡಿವೈಸ್ ಕೂಡ ಸಿಕ್ಕಿಲ್ಲ, ಬೇರೆ ಯಾವ ರೆಸಿಸ್ಟೆನ್ಸ್ ಕೂಡ ಸಿಕ್ಕಿಲ್ಲ. ಸೊ ಇಲ್ಲಿ ಎಷ್ಟಾಯ್ತು? ಇಲ್ಲಿ minus 10 ವೋಲ್ಟ್. ಸೊ ಇವೆರಡರ ಮಧ್ಯೆ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫ್ರೆನ್ಸ್ ಎಷ್ಟು? 10 ಮೈನಸ್ ಆಫ್ minus 10, 20 ವೋಲ್ಟ್. ಇಲ್ಲೂ ಕೂಡ 10 ಮೈನಸ್ ಆಫ್ minus 10, 10 ವೋಲ್ಟ್. ಈ ಪಾಯಿಂಟಿಗೆ ಬಂದೆ, ಇಲ್ಲಿಂದ ನೋಡಿ ಈ ಟರ್ಮಿನಲಿಂದ ಈ ಟರ್ಮಿನಲ್ಗೆ ಹೋಗ್ತಾ ಇದ್ದೀವಿ. ದರ್ ಇಸ್ ನೋ ಪೊಟೆನ್ಷಿಯಲ್ ಡ್ರಾಪ್. ಸೊ ದಿಸ್ ಇಸ್ ಆಲ್ಸೋ 10 ವೋಲ್ಟ್. ಆ್ಯಂಡ್ ಹಿಯರ್ ಫ್ರಮ್ ದಿಸ್ ಟರ್ಮಿನಲ್ ಐ ವಿಲ್ ಮೂವ್ ಹಿಯರ್ ಆ್ಯಂಡ್ ದರ್ ಇಸ್ ನೋ device in between these 2 points, no drop, minus 10 volt. Here also potential is same. So that means in the series combination, I don't want you to write this, just I wanted you to understand this. So I am erasing all these numbers. This is only for understanding purpose. Am I clear with this? Understanding purpose. So that means potential across each capacitor is same. Potential across each capacitor is same. Prati capacitors across same potential ide. Okay, now how much is the charge stored here? How much is the charge stored? Okay, let us discuss that. Let us assume this positive plate sends plus Q here and this plus Q. Okay, it has 3 routes to travel, not single route, 3 routes to travel. So sum of charges will go this way, sum of charges will go this way, and rest of the charges will go in this way. Howdalva? So ಇಲ್ಲಿ ಅಕಸ್ಮಾತ್ ನಾವು ನೆಗೆಟಿವ್ ಚಾರ್ಜಸ್ನ, okay, so from the negative terminal negative charges will be given towards this side. Here we have a charge minus Q. Will the same charge go here? Will the entire Q will go to the capacitor 1? No sir. ಇಟ್ ಹ್ಯಾಸ್ 3 ರೂಟ್ಸ್. ನೀವೇ ಯೋಚನೆ ಮಾಡಿ ಮಕ್ಕಳ, ಇಲ್ಲೊಂದು ಪೈಪ್ ಇದೆ, ಈ ಪೈಪನ್ನು ನಾವು 3 ಓಪನಿಂಗ್ಸನ್ನ ಇಟ್ಟಿದ್ವಿ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. ಇಲ್ಲಿಂದ ನಾವು ವಾಟರ್ನ ಬಿಟ್ಟರೆ ಏನಾಗುತ್ತೆ? ಇಲ್ಲೂ ಒಂದು ಸ್ವಲ್ಪ ಆಗುತ್ತೆ, ಇಲ್ಲೂ ಒಂದು ಸ್ವಲ್ಪ ಆಗುತ್ತೆ, ಇಲ್ಲೂ ಒಂದು ಸ್ವಲ್ಪ ಆಗುತ್ತೆ. ಸೊ ಇಟ್ ಹ್ಯಾಸ್ 3 ways. ಸೊ ದಿಸ್ ಚಾರ್ಜ್ ವಿಲ್ ಬಿ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟೆಡ್ ಅಕ್ರಾಸ್ 3 ways. ಸೊ ಲೆಟ್ ಅಸ್ ಅಸ್ಯೂಮ್ ದ್ಯಾಟ್ ಔಟ್ ಆಫ್ ದಿಸ್ ಟೋಟಲ್ ಚಾರ್ಜ್ Q, some charge Q1 minus Q1 goes to this plate and minus Q2 goes to this plate and minus Q3 goes to this plate. So minus q, capital Q बदलो small q बरेना sir. Okay, no problem. You can write small q. Q1, Q2, Q3 is equal to total charge Q. Okay. If this plate has minus Q, this plate will get plus Q1. This plate has got minus Q2. This will get plus Q2. Opposite charges to induce madte. Here on this plate there will be minus Q3. Okay. So that means we have understood two important things. Potential difference across each capacitor is same. This is the first point I am writing. This is very important. Potential difference. Potential difference across each capacitors in parallel combination is equal. What is the next important thing we should write? Okay, what is the next important thing? We will write it here. I will write it here. Charges, different amount of charges will be distributed across capacitors considered. ಈ ಕಾಂಬಿನೇಷನ್ ಅಲ್ಲಿ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಿರೋ ಕೆಪಾಸಿಟರ್ಸ್ ಅಲ್ಲಿ ಎಲ್ಲದರಲ್ಲೂ ಏನು ಚಾರ್ಜ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆಗಿದೆ, ಡಿಫರೆಂಟ್ ಆಗಿ ಚಾರ್ಜ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆಗಿದೆ. ಐ ಆಮ್ ಕ್ಲಿಯರ್ ವಿತ್ ದಿಸ್ ಇಸ್ ಆಲ್ ಯು ನೀಡ್ ಟು ನೋ. Very simple. Look here, potential difference across each capacitor is same. Charges distributed are different in this case. Okay, and I will now draw an equivalent circuit which contains equivalent capacitor. Now I will write a capacitor here. I will term the capacitance, equivalent capacitance of this capacitor as Cp, and we will apply same voltage. We will apply same voltage as here. Here, what is the potential difference across this battery? That is V. Here also it is V. How much is the charge given here? Plus Q. Here from this side minus Q. So this plate has plus Q. This plate has minus Q, which is equal to charge given to these capacitors. ಈ ಮೂರು ಕೆಪಾಸಿಟರ್ಸ್ಗೆ ಎಷ್ಟು ಚಾರ್ಜ್ ಕೊಟ್ಟಿದ್ವೋ ಇಲ್ಲೂ ಕೂಡ ಅಷ್ಟೇ ಚಾರ್ಜ್ ಕೊಟ್ಟಿದ್ದೀವಿ. ಈ ಮೂರು ಕೆಪಾಸಿಟರ್ಸ್ಗೆ ಎಷ್ಟು ವೋಲ್ಟೇಜ್ ಕೊಟ್ಟಿದ್ದೀವೋ ಇಲ್ಲೂ ಕೂಡ ಅಷ್ಟೇ ವೋಲ್ಟೇಜ್ ಕೊಟ್ಟಿದ್ದೀವಿ. Am I clear with this? This capacitor is equivalent capacitor. So the capacitance provided by C1, C2, C3 in parallel is equal to capacitance provided by this capacitor. Okay, how much is the capacitance? Q is equal to Cp is equal to Q by V. Am I clear with this? Now, and what is Q is equal to? C into V. Cp into V. Now, look here. Cp is equal to Q by V. C is equal to what? Q by V. That we have already discussed. And Q is equal to Cp into V. That is capacitance into, what is the charge distribution, charge consumed? Capacitance into potential difference. Now, total amount of charge. How much is the total amount of charge distributed to capacitors? For this capacitor Q1, this capacitor Q2, and this capacitor Q3. And this is the total charge, which should be equal to the total charge Q. Total charge Q. Am I clear with this? Okay, now we will substitute. What is Q? Cp into V. Q is the charge provided to the capacitor. Total charge is Q. So that can be represented by Cp into V. Cp into V is equal to, how much is Q1? How much is Q1? Come on. What is Q? Capacitance into potential difference. Across this capacitor, what is the potential difference? Sir, V, sir, same. Okay, V. What is the charge? Charge is Q1. How much is the charge? Capacitance into voltage. That is, capacitance across this is C1, and what is the voltage across this? V. And now Q2. Q2 is the charge distributed in the capacitor 2. Now, what is the potential difference across this V? What is the capacitance? C2. So, charge on this capacitor Q2 is equal to C2 into V. So, that is C2 into V plus for C3, for Q3, that is C3 into V. Q3 is the charge distributed on this capacitor. Potential difference across them V. Charge capacitance C3. That's it. So now we take V common. So V, if we take V common here, V is equal to C1 plus C2 plus C3. So this gets cancelled. So capacitance, equivalent capacitance in the parallel combination is equal to what? Sum of capacitance of each individual capacitors. Let us write it. This is what? Equivalent capacitance in parallel combination. Equivalent capacitance is equal to sum of capacitances of each individual capacitors. See, this is very easy. Look here, I will write a note here. We have 3 capacitors, 2 microfarad and another 5 microfarad and another 4 microfarad. Sorry, I wrote it wrong. This is connected in series. I should not be writing this. Okay, this capacitor, and this capacitor. And these capacitors, 2 microfarad, 5 microfarad, 6 microfarad I will write. What is the total capacitance of this combination? 2 plus 5 plus 6. How much is that? 13 microfarad, which is more than the biggest capacitance. In parallel combination, if you connect the capacitors, number of capacitors in parallel combination, the equivalent capacitance is more than the largest capacitance. That's it. So, ಈಗ conclude ಆಯ್ತಲ್ವಾ? Capacitance ಜಾಸ್ತಿ ಮಾಡಬೇಕು, ಇರೋ capacitance ಯಾವ ಥರ ಕನ್ಸಿಡರ್ ಮಾಡೋಣ? ಪ್ಯಾರಲೆಲ್ ಆಗಿ ಕನೆಕ್ಟ್ ಮಾಡೋಣ ಸರ್. ಇರೋ ಎಲ್ಲ ಕೆಪಾಸಿಟರ್ಗಿಂತ ಕಮ್ಮಿ ಕೆಪಾಸಿಟೆನ್ಸ್ ಬೇಕು, ಸೀರೀಸಲ್ಲಿ ಮಾಡೋಣ ಸರ್. ಅದ್ಯಾವುದೋ ಇನ್ ಬಿಟ್ವೀನ್ ವ್ಯಾಲ್ಯೂಸ್ ಬೇಕು, ಮಿಕ್ಸ್ಡ್ ಕಾಂಬಿನೇಷನ್. ದ್ಯಾಟ್ಸ್ ಇಟ್, ದಟ್ ಇಸ್ ವೆರಿ ಈಸಿ. ಈಗ n ನಂಬರ್ ಆಫ್ ಕೆಪಾಸಿಟರ್ಸ್ ಇದೆ, ಪ್ಯಾರಲೆಲ್ ಆಗಿ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ದಾರೆ. ಹೌ ಮಚ್ ಇಸ್ ಇಟ್ಸ್ ಕೆಪಾಸಿಟೆನ್ಸ್? n into c. Add them all. If they are equal, n into c. If they are different, just add them. That's it about series capacitors, series combination of capacitors and parallel combination of capacitors. Okay, thank you.